Hello class, welcome back to Chemistry 2. This is Sir Alexis Pasco again, and today we'll be discussing our lesson 2, which is the liquid state. Today we'll be talking about liquid and the properties of liquid. And the goal for today's class is for us to be able to describe the properties of liquids and explain the effect of intermolecular forces on the following. So these are the properties of liquids. One is surface tension, two is viscosity, third vapor, fourth boiling points, and lastly molar heat of vaporization. So we'll be discussing each of these properties and how intermolecular forces affects each of these properties. Let's start with the liquid state. So some of the general properties of liquids are 1. Surface tension, viscosity, vapor pressure, boiling point, and molar heat of vaporization. As gases condenses at lower temperatures, they turn into liquids. The intermolecular forces exhibited by the molecules in the liquid determines the mentioned general properties. Remember, in lesson 1, we discussed that the properties or characteristics of a matter is highly dependent on the intermolecular forces between the molecules. So the same thing is true for each properties of liquid here. So the surface tension, viscosity, vapor pressure, boiling point, and molar heat of vaporization changes depending on what kind of depending on the intermolecular forces that is affecting the molecules or particles present in the liquid. Let's start with surface tension. So surface tension is the property of the liquid to resist an external force by assuming a smaller surface area. What do you mean by that? So the assumption of a smaller surface area results in the formation of a surface on the resting liquid. So I think if guys, this it's been a year for Olympics, and I'm not sure if you guys have watched the Olympics, but one of the sports there is diving. So one of the things that the divers constantly are in mind about is the surface tension. Because if you fall from a very high place into a resting pool, you're basically falling onto a piece of concrete. That surface on top of the resting liquid uh, can be very dangerous. So when they dive off the diving board, they sort of create a way to puncture the surface of that liquid in order to break the surface tension. Otherwise, if they fall flat, it will be very painful for them. This is because of the intermolecular forces exhibited by the molecules of the water. or not only water, but let's say the liquid. So here we know that the intermolecular forces present in water is what we call hydrogen bonding, and this hydrogen bonding is very strong. For a single molecule of liquid, in this case water, which is H2O, anything below the surface of the liquid, they're all connected to other four individual uh, molecules of water. So example right here, we have one molecule of water and it is connected to other four molecules of water. But when we look on the surface of the water, it is only connected to the molecules on its surface and the ones below it. So it doesn't have any way to connect on the top because on top it's already gas. So there's no water molecules on top. So what they do is it creates a more stronger connection to its neighboring or the molecules beside it. And this stronger bonding between the molecules on the surface of the water creates the surface tension. And this surface tension is actually very strong, that it makes it possible for some insects like the water strider to walk on water, or sometimes for the water to even hold a paper clip on its surface. So if you have a glass of water, you can drop a paper clip on top of it. Even though the paperclip can be metal, it doesn't sink because of the surface tension. It is also the reason why droplets form a dome shape. So if you guys have seen when it's raining and after the rain you sometimes see droplets of water and they created a dome shape. And the reason that it creates a dome shape is because it assumes a smaller surface area, it bends off in itself and it creates a dome, and because that's because of surface tension. Here is a moving picture of a water strider sort of walking, or in this case jumping on the surface of the water. It doesn't sink because of the surface tension of the water. Next, viscosity. When we talk about viscosity, this is the property of water to, or property of a liquid to, resist flow or change its shape. So you can think of viscosity as basically the thickness or the thinness of the water kung gaano siya kalapot. So we have some examples of viscous liquids here, like example as a glue. We also have an olive oil and even honey. So they have various uh, degree of thickness in them, and we know that honey is very sticky, it's very thick compared to, let's say, an olive oil. And one way to measure this, are actually two ways to measure viscosity. One is to get a liquid, put it in a cylinder, and drop a metal ball. So the time it takes for the metal ball to arrive to the bottom of the liquid, you can use that to measure the thickness or the viscosity of the liquid. The same thing here, you can time the amount it takes for the liquid to basically drop from the tip to the floor or to the container where you're collecting these liquids. So greater intermolecular forces means the more viscosity and vice versa. So for example, let's compare water and honey. Water is less viscous than honey. It's because there are more intermolecular forces, or there's a stronger or greater intermolecular forces between the molecules of honey compared to the molecules of water. Temperature also affects viscosity. At higher temperatures, some liquids become thinner. This is a classic example with olive oil. So olive oil, when it's colder, it's more viscous. But when you heat it up in the pan, it becomes more looser. It becomes thinner. So intermolecular, and again, this is still related to the movements of the molecules inside that liquid. No, in this case, the olive oil, because as you increase the temperature of the olive oil, some of the intermolecular present in the particles of the olive oil breaks apart, so it makes the olive oil thinner. So it has less intermolecular force. So the take on viscosity is that higher intermolecular force means more viscous. Lesser intermolecular force, the thinner the liquid. Temperature as well, higher temperature makes the liquid less thicker, and on colder temperatures, that makes the water or the liquid thicker. Next is vapor pressure. So when we talk about vapor pressure, is basically the amount of gas particles of that liquid present in a container. So let's think of this as an example. So when liquids are evaporated, the liquid molecules overcome their intermolecular forces and becomes gas. We've discussed this, and I think it's in lesson one. We talk about how liquid, in this case this bottom right here, this liquid has intermolecular forces, and as you heat it up, the particles starts moving faster, and as they continually heating up, as they collect more kinetic energy, they finally break out, they overcome those intermolecular forces and they become gas. This particle escapes liquid and they become gas. So when you evaporated a liquid in a closed container, the gas molecules cannot escape, And what happens, it exerts a pressure on the walls of the container. So we can imagine this as a closed container. Okay, as you heat it up and half of it is liquid, and you heat up this container, and as the liquid heats up, some of the particles eventually become gas, but the gaseous particles are stored inside the container. And what happens is that as this vapor pressure or these gas particles are trapped in the liquid, they exerts force outside onto the surface of that container. And that pressure or that force from this vapor molecules is what we call vapor pressure. You can think of some, it may be counterintuitive to think that gas has a force, but you can think of it as a blowing a balloon. Kapag hinipan mo yung balloon, it expands. It's because of the gas molecules inside the balloon pushing onto the surface of the balloon for it to stretch. It's kind of like the same principle applied here, but it's on a container. So as the liquid heats up, gas the particles from the liquids changes phases from liquid to gas, and as they become gas, they exert force on the wall of the container. And that pressure that these gas particles exerts is what we call the vapor pressure. Liquids with lower intermolecular forces evaporates quicker and have higher vapor pressure, while higher intermolecular forces evaporates lower and has lower vapor pressure. So in this case, the intermolecular force is inversely related to the vapor pressure. Kapag mahina yung intermolecular force ng liquid, mas mabilis siya mag-evaporate. So if it is faster to evaporate, it means mas mabilis mag-release yung gas from the liquid. It means mas mataas yung vapor pressure sa taas. So ibig sabihin, mas marami yung gas molecules on the surface on top of the liquid. But if the intermolecular force of the liquid is higher, mas matagal na ma-release yung gas particles. So mas matagal na mag-change yung phase from liquid to gas. So it means there's lesser vapor pressure on the top of the surface of the liquid, hence there's less vapor pressure. Next, boiling point. So when we talk about boiling point, it's basically the temperature at which liquid boils and turns to vapor. It's related to vapor pressure because in order for the liquid to turn to gas, you have to boil it. And when the temperature of the liquid is increased, the kinetic energy of the liquid particle increases, and as they continually increases, they keeps moving and moving until such time again that they overcome the intermolecular forces and they switch phases from liquid to gas. An example is a moving picture right here. As you heat up the water molecules, they keep moving and moving until such a time they overcome the intermolecular forces and they turn into gas. And you can see that in a boiling liquid, there are sometimes bubble forms in the liquid when boiling liquid. So the gases phase of this, yung bubble is actually is the gas phase of the same molecule. An example, we have water here. As water particles are heated up, you can see bubbles forming and they rises. So yung gases sa loob ng bubble, it's not a composition of hydrogen and oxygen gases. It's still a H2O gas, but in gaseous form. Okay, I hope you guys catches that because when you heat it up, for example here, water, hindi bigla-bigla mag-break yung bonding between the hydrogen and the oxygen. Remember, that's intramolecular force. What we're breaking here is the intermolecular force. It's the connection between H2O. So the liquid H2O, when they break apart, this H2O is still the same molecule as it is when it is water, but this time it is just in its gas phase. Again, another thing about boiling point is that more than thermomolecular forces, the atmospheric pressure is also important in determining the boiling point. Boiling point again is the temperature, but the atmospheric pressure is a pressure exerted by the atmosphere. We're basically living in a sea of atmosphere. So all around us is surrounding us is yung atmosphere natin is composed of carbon, oxygen, nitrogen, etc. And all of these gas molecules are exerting pressure onto us. So this pressure is what we call atmospheric pressure, and yung unit na ginagamit natin is millimeters per millimeter mercury and at ATM or atmosphere. So when we are at sea level, so meaning where we are right now, where we are living at sea level, the atmospheric pressure is 1 atmosphere. And this atmospheric pressure exerts its force on the water. So if we go back here, so imagine this is an open beaker. On top of this open beaker is your atmosphere which surrounds us. And this atmosphere also exerts pressure downward, preventing the water molecule to actually leave the liquid, preventing the oxygen molecules to leave the water surface. So what happens is that until the vapor pressure of the water is equal to the atmospheric pressure, only the gas particles on the surface of the liquid escapes. So what that means is that at sea level, alam natin na yung temperature to boil water is actually 100 degrees. So when the water reaches 100 degrees, the water starts to boil. The bubbles form, and gas particles, the water particles turns into gas, and it leaves the water molecule. And this is because the vapor pressure being exerted as the water boils is equals to the atmospheric pressure present in at sea level. Pero kapag nag-boil tayo ng tubig sa higher altitude, the atmospheric pressure top on higher altitudes is actually less. So, for example, if you boil it on top of, for example, Mount Everest, mas mababa yung boiling temperature. Bakit? Kasi mas mababa yung atmospheric pressure. So it takes lesser energy to boil the water for the vapor pressure of the water to equal the atmospheric pressure present at higher altitude. So it takes lesser energy to shift the liquid to gas phase. Again, so intermolecular forces and atmospheric pressure contributes to the boiling point of a liquid. Okay, so again, atmospheric pressure exerts a pressure on the surface of the water, which makes it impossible for the gaseous phase of the molecules of the liquid to escape. But as you boil it and the vapor pressure becomes equal to the atmospheric pressure, the gaseous phase of the liquid starts to finally escape. So when you lessen the atmospheric pressure by going at higher altitudes, for example, boiling water while flying on a plane, mas mababa yung temperature na kailangan mo to boil the water. Lastly, is molar heat of vaporization. So molar heat of vaporization, which is what we call the delta H vap, here is the heat required to vaporize 1 mole of liquid. When we talk about heat here, we're not talking about temperature, we're talking about energy. So basically the amount of energy you require to vaporize 1 mole of liquid from to gas at boiling point at 1 atmosphere, so meaning at sea level. When we talk about mole and molarity, is a standard unit to measure a large quantities of very small units of atoms. So when we talk about mole, we're basically talking on how many um, atoms there are in a particular substance. So in order for us to vaporize 1 mole of liquid is the molar heat of vaporization, how many energy it takes to vaporize 1 mole of liquid. So we're not gonna discuss more about molar heat of vaporization. We'll discuss it later on in a different lesson. But these are the table for the molar heat of vaporization. This is the energy that you need, which is in kilojoules. So joules is the units for heat, energy. This is the amount of energy that you need in order to vaporize, for example, 1 mole of liquid helium. And they usually boil at negative 269 degrees Celsius. So that's all the properties of liquids. So if you guys have any questions, again, do not hesitate to ask me. And thank you guys for listening. And have a good day.